Now let us see, this problem says, so how would you synthesize using aldol, glycine or other condensation reaction to make each of the following compound. So part A says, so you have this molecule, so there is a 5-membered ring, and this side you have this, and then this side again you have a 5-membered ring, and there is a CHO group attached on this carbon, and there is a double bond between this carbon and this carbon. And the question asks, how would you prepare this compound using any kind of condensation reaction. So let us back in the backward direction. You see, this compound I can form from dehydration of this compound. So if you have this, so I can make this compound using dehydration of this compound. So if I have this compound, if I do dehydration, that is minus H2O, I will get this compound, that is alpha beta unsaturated carbonyl compound. I am getting from beta hydroxy keto compound. So this is a beta hydroxy group. At alpha position I have a keto compound, so carbonyl compound, so beta hydroxy keto. Now this I can prepare. You see, how can I prepare this? I can prepare this if I attack something on this. So this is very easy to think. I can prepare this compound if I take this COH. Are you getting or not? And plus same compound if I take again this side, CHO, or I can write CHO. So if I take these two compound I can get, what we will have, I will get a minus here. If I trade with base, this attacks here. So you see, you are getting the same compound. So this means if I do aldol condensation of this molecule, so this if I do self aldol condensation, I will get the desired product. So this compound after the self aldol, it will give you the same compound, that is desired product. I think all of you are getting one. So you have to do in the reverse way. So you think in the reverse direction. How will you prepare the first compound with elimination of H2O, and then you think in terms of reverse. Let us do part B. So how can you prepare this compound? So again I have, so let us say I am writing 5-membered ring as R. It is easy to write R. So I have R double bond CO, and here I have COOET, and here I have R. So I want to prepare this compound. How we can prepare this one? So let us think. So you have R, CH2CO, COOET, and this side again you have R. Basically in this case R is a cyclopentane ring. So R is nothing but, this is a cyclopentane ring. So R is equivalent to cyclopentane ring. So let us see how many of you can do this one. So I am waiting for some time. So let us see how many of you can give the answer for this problem. It seems if I break this bond, this is there is some minus, so carbon ion that attacks here, and if there is a leaving group that can leave, so I can get the desired product. So what can I do is, so if I take this compound RCO, and let us say if I put a leaving group OET, and this side I have R, and this is CH minus, so let us say minus I have, and this side again I have COOET because I require COOET. So let us say I have CO OET here at this position. In that case, I will get the desired product. This minus will attack on this carbon and this will open, and the next step it will leave. So I will get the desired product. This means I can get this simply RCH2COOET. And this compound is same, RCH2COOET. So this means if I take 2 molecules of this, I will get the desired product. And this reaction is nothing but Claisen condensation, self. So this molecule is again condensing with the self molecule. So this is called self Claisen. So self Claisen, CLAI, Claisen. So this is called self Claisen condensation. Now let us discuss the next one. Now C you have, so let us copy. So C part you have, so you have a 5-membered ring, and this side you have C double bond O, C double bond O, and there you have C CH3 whole 3. So how will you prepare this compound? So let us think. So now in this case you have 2 options. So if you break this bond, so what can you do is, if you take a leaving group here attached, so if you take this COOET, and if you take this side a carbon ion, that is CO CCH3 whole 3, and here if you have CH3, and if you treat this with OET minus, that is a base, in that case what will happen? You will get a carbon ion, this carbon ion will attack here, this goes. So this is a one way to make this compound. Are you getting or not? Another way will be, so this is a basically mixed Claisen. You see you are taking one compound and different compound. So this is a mixed Claisen condensation. So if you want I can write, so this is a mixed Claisen. Now if you wish, you can make the same compound by breaking this bond. So let us say you have this. Now if you break this bond, again you can get, so what can you do is you can make COET this side, and this side you can make carbon ion. So you can have this COCH3 plus CO, and this side let us say you have a leaving group attached. In the first case you have taken leaving group this side, now in this case you can take leaving group this side OET, and this side you can have CH3 CCH3 whole 3. Now if you treat this compound with OET minus, you will get the desired product. Again in this case this is again a mixed Claisen condensation reaction. So this is mixed Claisen. Are you getting or not? Let us discuss next one, D part. I think all of you have copied this one. So you have this. Now you see how will you prepare this compound. So this is again, there is a double bond. So you have to think in terms of alpha beta unsaturated carbonyl compound can be prepared from beta hydroxy keto compound. So you can prepare this by dehydration of, so if you have OH here and H here, and if you release H2O, that is dehydration, if you simply heat, you will get this compound. Now I need this compound. How can I prepare this? So I can prepare this. So I need here OH. So this means there will be some attack. So I can take this compound. COCH3 if I take here. And this side if I take PHCHO. So in that case, and if I treat with base OH minus, this CH2 minus will attack here, and then you will get the same compound. Of course, you have to acidify also the solution so that O minus can be converted into H plus. Or even O minus can take H plus from water and it can form alcohol. So if you see, this is an example of aldol kind of reaction, but this is a mixed aldol. So this is a one and this is another compound. So this is a mixed aldol. So if you have written this one, let us discuss next part, that is easy one. We have two more parts. So let us say E part. This says I have this compound, double bond O here, and this side double bond O, and this side I have pH. How can I prepare this compound? So once again you have something COET kind of thing. So if you think this bond, what can you do is you take minus here, so you can take this simply cyclopentanone, and this side if you take pH, CO and OET, and if you treat this 2 with OET minus, so let us say if you treat this 2 with OET minus, what will happen? OET minus will make a carbon ion here, and this carbon will attack here, and this lithium group will goes. In that case you will get the same compound. Let us discuss F. Now in this case we have this compound, and there is a CH3, CH2, CH3. So once again you have a double bond. You think in terms of alpha beta unsaturated carbonyl compound. So you can prepare this compound from, there is a CH3 and there is a ET. So you will have at beta position OH group. So dehydration of this will give you this compound. Now how will you prepare this? So it can be basically intramolecular aldol condensation. You will have CO, and here if you have CH3, and let us say here you have C double bond O, and then you have ET this side. And now if you treat this compound with OH minus, you will get the desired product, because what OH minus will do, this will make carbon ion here, and this carbon ion will attack on this carbon, so these two carbon will get connected, so you will get a 6-member ring. So this is example of intramolecular aldol. So this is intramolecular aldol. Okay, let us discuss the next reaction.